My name is Dan Dimler, and today we'll be looking at optimization techniques in daily fantasy sports. So a little background in daily fantasy sports. It's been growing a lot in the last 10 years. The fan base has tripled from about 15 million to a little under 60 million in 2015, really under the premises that you can play weekly tournaments without any season-long commitment. The gameplay in daily fantasy sports is pretty much the same from site to site, depending on what interface you play on. Users are given a fantasy salary, and each athlete has a cost from that salary. So any combination of players can be chosen as long as you stay under that fantasy salary cap. From there, the players play in the games and score fantasy points. The top lineups that score the most fantasy points win the tournament. So the application in daily fantasy sports presents a combinational optimization method. We're to maximize the sum of the fantasy points per game under the given constraints of salary and player position. So why research optimization methods in daily fantasy sports? Well, we want to understand how these algorithms are developed in order to achieve the maximum fantasy points per game score, as well as utilize the mass amounts of data that is added in sports every day that we have access to. Also, professional daily fantasy sports gamblers use optimizers with a 90 to 95% success rate winning tournaments that often. So given our constraints, we're looking at a combinational optimization problem of a 0-1 knapsack problem. We're to maximize the value of an item subject to the item's weight given the maximum weight capacity. And 0-1 meaning we either choose the item or we do not choose the item fully. Relating this in terms of daily fantasy sports, we are to maximize the 9 items chosen. The items being the fantasy football players, the value being the fantasy points per game, the weight being the salary cost, and the maximum weight capacity being the total salary cap of the 50,000. So formulating a model, we're looking at the density of each player. So we want the players with the best fantasy points per game per dollar. We also want to analyze the possible floors and ceilings of each player. We want high-performing players and consistent players as well. The game objective is to achieve the highest fantasy points per game sum, and the game is won if we score in the top 50th percentile of the tournament. On average, this equates to around 150 fantasy points. So as a check, a player costing $9,000 would have to score 27 points to cover their value, whereas a player costing $4,000 would only have to score 12 points to score their value. So formulating our algorithm, we're using Microsoft Excel solver function using the simplex LP linear programming method, which uses linear constraints of decision variables, searching a discrete search space, bounded variables for positions, and then a branch bound method. The results give us a convex solution with a global optimum. So yielding the results of our optimizer, we were able to find a global optimum score of 163.872. The approximate runtime was 10 seconds. Below is the optimized lineup, and to the right were the solver constraints used. So in doing so, we know that we can never truly achieve the optimum score just by numbers alone. Anything can happen in sports. However, this does provide us more of an edge over our competition. So continuing work, we know that our optimizer is not bulletproof. However, using an optimizer, we already have a better advantage over somebody that is not using optimization techniques in daily fantasy sports. Continuing work, we'd like to generate multiple lineups, estimate the projected exposure of each player, finding floors and ceilings in each of their volatility rates. Also just get bigger data stats such as year-over-year player stats, as well as incorporate Vegas odds and scoring, simply because Vegas is usually pretty accurate in their scoring.